Hello everyone, hope you're having a nice start to the week. I'm just going to talk a bit about trigonometry and then get you to do some work on 13b. If you zoom in on this triangle here, we've spoken already about the sides of a triangle. If I have my angle theta here, theta is just a Greek letter that represents an angle. The hypotenuse is always this longest side, always the longest side, and the opposite side is the one that's opposite. So that leaves us with one side, which is adjacent. Now, if my angle was up here, then the opposite and the adjacent would switch because my opposite side is opposite that angle. But we need to sort of look at each triangle as we go. Now, you would have seen in year 9 that there's some trigonometric ratios we've been talking about. And so this is the following. The sine theta is equal to, and that's just a value, is equal to opposite over the hypotenuse, sometimes referred to as sine theta equals O over H. Cos theta is equal to A over H, adjacent side, the length of the adjacent side over the hypotenuse length. And then the length tan theta ratio is equal to opposite side over the adjacent side. SOHCAHTOA, SOHCAHTOA is what you sometimes hear. You may have looked at that. So if you have a look at this particular triangle, it's a right angle triangle, it always has to be in our case, 3, 4, and 5. It's always a good idea to label. So this is the hypotenuse, HYP, I'll label this. 4 is opposite because theta is here. The angle we're interested in is up here. So 4 is opposite, so that's the opposite side, and 3 is adjacent. So if I was to ask, well, what's the value for sine theta, cos theta, and tan theta? Well, sine theta is the opposite side, which is 4, over the hypotenuse, which is 5. So that's going to be 4 over 5, or if it's a decimal, it's 0.8. Cos theta is the adjacent side, A over H, which is equal to 3, because 3 is the adjacent side, and the hypotenuse is over 5. And that, again, it's 0.6 if we're interested in the decimal. And then tan is opposite over adjacent, which is equal to 4 over 3. Opposite side is 4, adjacent side is 3. So that's equal to 1.3 repeater if we want it as a decimal. Now, the trick is we can use these ratios to find the lengths of unknown sides in triangles, which is what we're going to do. So let's have a look at a couple of examples. So question 1, we've got this triangle here. We've got 53 degrees 12 minutes down here. We've got 16.2 centimeters over here. And then we've got x over here. All right, so what do we need to do? Well, we need to find what x is, because that's what we're interested in. But first thing you always do is you're going to label the sides. This one is hypotenuse, and the side x would be its opposite side. So we've got the opposite side and we have the hypotenuse. Now, which ratio involves the opposite and the hypotenuse? Well, the answer is sine. So what we write is, use the sine ratio for question 1. So we now write an expression. Always write this expression out. Sine 53 degrees and 12 minutes is equal to opposite, which is x, over 16.2. Now we have an equation. We have an equation that we're able to then solve. So we're going to do that. Now, before I find all these things, I've actually got to work out what sine 53 degrees and 12 minutes is. Now, it just so happens that 12 is 1/5 of 1 degree, but that's not really interesting for you. So we are going to do the following. Let's find that. So I'm going to type that into my calculator. Sine 53 degrees and 12 minutes. And that's equal to 0.8. Now we've got to do this to a few decimal places because my final answer will be 1 decimal place. 0.5007 equals x over 16.2. Now what I need to do is get 16.2 out of the denominator, so I'm going to multiply both sides by 16.2. This is a pretty standard procedure that we need to do. So I'm going to get x on its own on this side, and on this side we're going to get 0.8007 times 16.2. If I flip that around, now if I multiply that using my calculator, times 16.2 equals, and I get 12.972. Always good to write to a few decimal places, which is equal to 13.0 centimeters, and that's to one decimal place. You notice how I've written it to a few decimal places, so I see the answer from the calculator and then I do the rounding. Alright, so see the process we went through. Identify the sides, write that in, then think what ratio do I need to use. In this case, it's the opposite side in the hypotenuse, so I'm using sine. I write my expression, sine of the angle, which is 53 degrees and 12 minutes in this case, is equal to x, which is the side we're trying to find, over 16.2. Then we solve that equation using this technique and we get 13. All right, let's try this number 2. Number 2. And all this is in the OneNote under a new tab of trigonometry. You can look at it and go through it. Okay, so here we go. Now we've got to think, my angle's over here. Now, Z, well, that's the hypotenuse that we're trying to find because it's the longest side. 310, well, it's not opposite. The opposite side will be over here, so it must be the adjacent side. Now, if we've got the adjacent side involved and we've got the hypotenuse involved, which ratio has adjacent and hypotenuse? So we use cos ratio. Then we write the expression. Cos 21 degrees and 39 minutes is equal to adjacent, which is 310, over hypotenuse, which is Z. My Z's a bit funny. I'm going to change that. Z. All right, so that's what we have. Now, you notice that there's a trick here that we need to do with... First thing I'm going to do is find what cos 21 degrees 39 minutes is, because this can just save me a whole lot of effort to have to deal with that. And I'll write it to about 4 decimal places. So we're going to do cos 21 degrees and 39 minutes, and that's equal to about 0.9293. That's equal to 310 over Z. Now at this point, what we do is you take this value and the Z and you switch them. So if my X or Z or whatever I'm trying to find is in a denominator, I switch them around. So Z is equal to 310 over 0.9293, which is equal to 310 divided by 0.9293, and what are we going to find? It's going to be equal to 333.584, which is equal to 333.6 millimeters to one decimal place. I probably could do it to the whole. And you notice that my answer is probably confident it's correct because the hypotenuse, 333.6, is longer than the other side, which it needs to be. All right, so this one was different because we had the unknown thing. The thing we're trying to find is the hypotenuse. So we end up with the adjacent side over the hypotenuse up here. All right, the first one, we had the unknown in the top, which was the opposite over the hypotenuse. It just depends. You've got to take each one as it comes, right? Now, we're going to do this. I'll just move this down a touch. Let's do this last one. If you're thinking about it, you probably can anticipate which ratio we're going to use. We've got our angle here. Well, the hypotenuse is over here, but it's not part of the question. Just seems to be nothing involved. This is opposite because it's opposite the angle. So this x must be the adjacent side. Now, which of the three ratios involves opposite and adjacent? Well, it's tan, isn't it? Tan theta involves O and A. So here's what we do. We go tan of 41 degrees, 39 minutes is equal to opposite 52.9 meters over x. Remembering that it's opposite over adjacent. Now you notice again that our unknown thing, the thing we're trying to find, is in the bottom. So that's going to lead us to use our little trick. But let's find what 41 degrees 39 minutes is first. So we'll do that. Tan of 41 degrees and 39 minutes, I should say. Get 0.890. Actually, I take that back. I'm going to do it to 4 decimal places. So 8899, which is 52.9 over x. We're going to do our little switch. Take that, and we switch. That's my rainbow pen. You can all enjoy that. And so we get x is equal to 52.9 divided by 0.8899. 52.9 divided by 0.8899, which is equal to 59.4448. Always write it to a few decimal places, ... and when I round it to one decimal place, or 2, or whatever number, I can see what I need to do. 59.4 meters to one decimal place, and that's a reasonable answer. It's about the same, would make sense, right? If it was 45 degrees, it'd be exactly the same. So we're going to do exercise 13b. All questions, but just A, C, E of each. So don't do every second, just do 3 of each part and see how we go. Or 2 if it's just A and B and C. Okay, questions, let me know. Otherwise, go for it.